So welcome everyone to this session. I'm the session of this. I'm chair of this session, Akane Matsumae, associate professor at the Faculty of Design at the Kyushu University, Japan. This session is on semantic and perception in industrial design. Today, we have 4 insightful contributions in these sessions. Same as other sessions, after listening to the pre-recorded presentation, we will have interactive session. I'd like to ask you to write down questions and comments in the session chat during the presentation and the discussion. I do encourage and welcome the Q&A for the more fruitful communication. The first contribution we are going to introduce is the old and appreciated, exploring the influence of the materials aging on the aesthetic appreciation of the every products by Charlie Ranscombe. And the second one, we will not have that presentation today. And so the substantially the second one is the biomaterials in everyday design, understanding the perception of the designers and non-designers by the Ion. And then the next, how do semantic clues affect people's perception of products with multiple meanings, Yulan zone. And lastly, improving mixed reality prototyping through a classification and characterization of the fidelity by Chris. So to clarify who is the presenter 2, 3, 4, 5, please keep the number for the chat. Please indicate the number for the chat on the I for the third, and Yulan for the fourth, and the Chris is the fifth, please. So to avoid the confusion, please indicate the number, and also it's better to be indicated the name of the author too in the Q&A in chat box. So I'd like to start. I'd like to ask the Robert to play the first presentation, the one old and appreciated by Charlie.
Hi everyone, welcome to my presentation called Old and Appreciated. My name's Dr. Charlie Ranscombe from Swinburne University of Technology, and I'll be telling you about our research where we're exploring the influence of material aging on the aesthetic appreciation of products. So the motivation for this research comes from, an image like this. It's often said that we live in a throwaway society, and unfortunately, the throwing away of products isn't always just due to a loss of function, but rather a expectation for new things or to buy new products. So our approach to this problem stems from this idea of design for emotional durability. This is the idea that we might be able to design products which age gracefully or age in a way that stimulates us to cherish them and hold on to them for a bit longer, staving off the desire to throw them away. Now, this is a trend that certainly exists. There are plenty of examples of products where we really like the way that we ate. Now, this trend is not new. There are plenty of examples of products which are very much appreciated as they age. But what we don't know is how to explain this in terms of design research or in terms of product aesthetics. So when it comes to aesthetics, we do know quite a lot. We know that aesthetics can do a huge amount for products, whether it be the pure aesthetic value, they can communicate symbology, function, ergonomic features, and so on. So within that body of knowledge, we know that novelty and typicality are predictors of aesthetic appreciation. So typicality being how typical a product looks aesthetically, and novelty being how novel or new it looks. And that led us to our more specific research questions for this project. Does the appearance of aging in everyday products sustain novelty? Does it improve aesthetic appreciation? And can it decrease the willingness to discard products? So we tested this with an experiment in the form of a survey. We surveyed two classes of products, chairs and phone cases, and we artificially aged them through rendering software. So here is an example of some of the stages of aging of the chair with a copper material applied to it. And here is the example of the phone cases with timber material applied. So the design of the experiment was one where we had a control condition and an aging condition for each of those product and material combinations. We showed participants an image of the product and then asked them a series of questions, and then moved on to the next point in time where we, in the control condition, we show the same product, and in the aging condition, we show the product aged incrementally after a period of time. And so this was repeated for a total of 9 time increments. So let's talk about the findings. So in answer to our research question, does the appearance of aging sustain novelty and so on? Well, unfortunately, the answer is no. And with respect to the 4 categories of products, we saw that it was very much no for the 2 chairs, no for the timber phone case, and definitely not for the copper phone case. In that instance, the aesthetic appreciation was much lower and willingness to discard actually increased. So to explain what that means in terms of our data, what we had hoped for is that in the control condition, we would see appreciation, novelty go down, and that in the age condition, that appreciation would be sustained over time, likewise the novelty, and that the willingness to discard would be lower. However, what we actually saw is no statistical difference. So really, the fact that the products were aging versus the product which did not age at all attracted the same decreasing appreciation, novelty, and increasing willingness to discard. So what? Or what does that tell us? First and foremost, it proves that we have an expectation to discard products which is not just related to aesthetics or aging. But then secondly, we know it's a phenomena. So that leads us to, further research questions. What other factors might explain the effect? So in terms of further research, what we will be testing now is products with a fundamentally more novel design. So if the product itself looks a bit more novel and different, are we more willing to accept aging, and can aging sustain novelty? The other avenue for further research is to test other aesthetic qualities, and in particular, the symbolic aesthetic quality. So if we integrate an aging material, but in a manner which is symbolic of something, does that influence our willingness to discard and ultimately provide more sustainable products? So that's it for my presentation. Thank you for watching. If you're interested, this is paper number 149, and I'd love to field some questions that you might have on the presentation.
Okay, thank you for the presentation. I have aware that I'm sorry, I forgot to introduce Dr. Charlie before the presentation. So let me introduce him after the presentation. I really apologize for my mistakes. The Dr. Charlie Ranscombe is a researcher and a senior lecturer in industrial design and product design engineering at the Sweden University of Technology. His experience both as a practicing the industrial designer in the UK and China, as well as the academic design research at the University of Bath, UK. His research is interdisciplinary in domains, design practice, and the new product development with an emphasis on product aesthetic and the user experience. Because the reason why I would like to share each of the presenters here is the probably that could encourage the audience to provide the questions to help the questions to ask. So that's why. So, and then the next presentation is the on biomaterials in everyday design, understanding the perception of designers and the non-designers. This contribution is made by Nurul Sayuti University from the University of Technology, Mara, Malaysia, and Royal College of Art. Ian has been with the Industrial Design Department, Faculty of Art and Design, UITM Kedah, Malaysia, since November 2006 and is currently appointed as a senior lecturer. She is also the visiting associate researcher, previously appointed the postdoctoral fellow at the Royal College of Arts, London, and a part of the Immersive Innovation and Design RCA Research Group. Robert, could you start?
Hello and good afternoon. I'm Sayuti from the College of Creative Arts, University Technology Mara, Malaysia, and also a visiting researcher for Immersive Innovations and Design, I2D, School of Design, RCA, London. Today I would like to present about my research entitled Biomaterials in Everyday Design, Understanding Perceptions of Designers and Non-Designers. This research investigating the perception of potential consumers towards the use of biomaterials in everyday product designs. Within the context of biomaterials, the study is underexplored, unknown, and required further research. We are going to discuss the emergence of new trends in product designs within the framework of bio-related design genres, such as biophilic design, bio-inspired design, and so on, which are expected to lead a growing usage of biological materials. I'm going to explain in brief about the topics related to the studies. Biophilic design has progressed from biophilia theory, which was coined by Fromm 1973 and Wilson 1982. Akane 1994 discussed the advantage of being close to natural environments and human personal growth. Kellett et al. 2008 then introduced biophilic design to support humans' well-being regarding mind, emotion, and physical health in the environment. Biodesign, according to Maya 2018, is described as renewable and sustainable system effort that includes living biological materials or ecosystem. We move on to perception. Scientifically, where asserts that perceptions enter a cognitive system involved in seeing, thinking, and comprehending that shape our assumptions, belief, ideas, and knowledge about specific things or occurrences. Understanding the perceptions and emotional responses of users are important for design, and a number of researchers have explored this in relation to products, materials, and this provide foundation for this research studies. We have adopted Paris Mata 2017, 2019, Akane and Ahmed-Kristensen 2011, and also Goldman to classify consumer perceptions to better understand this knowledge. Research aims. The research aims specifically to investigate the emotional responses and perceptions of user towards biological materials and how these are affected when the materials are embedded within a product. The study will also further clarify the user perceptions towards biophilia, biophilic design, biodesign, identifying purposes and sense of ownership of product incorporating biological materials. Methodology. A research framework is developed to be the guideline for this postdoctoral project, and was structured in 8 stages, as you can see in the slide right now. To construct the survey, the researcher first identified the different types of biomaterials that are embedded in existing product designs. These biological materials were classified into 4 groups, which are artificial natural elements involving images of nature and artificial plants, real natural element plants, real natural element animals, and real natural elements microorganisms consist of fungi, algae, and beneficial bacteria. This is the example of the survey that was designed using Survey Gizmo, which consists of 6 main sections. And for this paper, we only discuss section B, which focus more on perception. This is the example of section B, which the questions on perceptions were asked to respondents based on the desirability, practicality, aesthetic, and common familiarity. We move on to the result, where a total of 234 responses were received and analyzed for this paper. And there are 38% of designers and 61% of non-designers involved in the studies. The respondents were asked to use a 7-point Likert scale to rate the level of desirability, practicality, aesthetically pleasing, and the common familiarity for the incorporation of the artificials and biological materials into everyday product design. As you can see, here are the descriptive analysis of mean value, ANOVA, and also non-parametric tests using SPSS. A mean score uses a scale of 3 for very, 2 for quite, 1 slightly, and 0 for neutral, mainly for positive and negative rating. The results are highlighted in yellow, mainly representing the significance findings and also the negative responses towards the materials. The graphs in the slide shows the overall result for material positive for desirability, practicality, aesthetics, and also for common familiarity. Finally, for conclusion, it could be concluded that real natural element plants receive the positive responses for the perceptions towards desirability, practicality, aesthetic, and familiarity, while the microorganism, fungi, algae, and beneficial bacteria perceive negatively. Insects also perceive negatively. Furthermore, this material have different connotations and understanding, and here we are looking into the perceptions by designers and non-designers. Overall, it can be concluded that the designers' perceptions tends to be more positive than the non-designers, as designers usually start experimenting and familiarizing with this material before the products are exposed to the consumers. This study is part of a larger project. Earlier work will publish, and future work will involve perceptions and emotional responses towards real biological materials to examine direct experiences. Thank you. If you have any questions, please do contact me.
Thank you for the presentation. And then the next is the how do semantic clues affect people's perception of products with multiple meanings by the Yulan Zhong. Yulan Zhong received a bachelor and master degree in arts from the Wuhan University of Technology in 2015 and 2018, respectively. She is currently pursuing a doctorate in empowerment informatics with University of Tsukuba. Her research interests includes product semantics and cognitive engineering's user interface. Please.
Hello everyone, my name is Zhong. I'm with the University of Tsukuba, and today I'm going to talk about the effect of semantic clues on people's perceptions. Here is an outline. Now more and more electronic products are being introduced to our daily life. Some are accompanied by complicated operations, which are often causing unpleasant experiences, especially for older adults. One of the most typical operations is select and confirm, and knobs are common to afford this. However, not all design could pass this information well. For example, the results from a usability testing we conducted indicated that sometimes older adults couldn't make the best use because they couldn't perceive the multiple operations of one physical controller. Although some problems have been attributed to physical or cognitive aging, many of them arise from the fact that the designers tend to rely on their intuition towards their designs. Krippendorf argued that artifacts should be designed to supply three qualities of experiences to achieve meaningful interfaces: recognition, exploration, and reliance. Exploration provides users with an understanding of how an artifact could be handled. Then he provided numerous concepts for exploration, such as constraints, affordances, informatives, and so on. Designers mainly have two ways to encourage or discourage meanings: the semantic way and the physical way. In this study, we mainly applied the concept of affordances and informatives to achieve the semantic way. Product semantics refers to affordances as the most reliable components of interfaces, which can be perceived directly. It follows that everyday objects are perceived in terms of affordances and have to be designed in terms of their users' abilities. Informatives are more like clues that indicate what can be done by the users. They indicate how to proceed and provide functions of like calling attention or concerning current stage or offering guidance. To be specific, the concept of affordance is quite fit, so we took this as one of the main conditions in this study. Such semantic clues have been studied by many researchers. However, there are very few empirical works that examine the relationship between semantic clues and people's perception. Furthermore, product designers are often combining different characteristics to convey multiple meanings. Few studies have examined such relationship, and it's still unclear whether semantic clues work for all users, and a more controlled method is also needed. So this study aims to experimentally elucidate how semantic clues affect people's perception of products with multiple operations and to verify their universality. So we first extracted basic shapes from the controllers we collected. And we made 48 samples of physical controllers with 4 parameters and treated them as within participant factors. We asked 16 older adults and 18 young adults to participate. After a constant interstimulus interval, a fixation cross appears on the screen. Then a randomly selected image or video stimulus was presented. Meanwhile, the first question and its options also appeared. After the participant finished the choose of question 1, the second question and its options appeared. We collected their selection and reaction time for data analysis. And we treated selection radio within individuals as a dependent variable since all participants saw each stimulus twice, and then conducted ANOVA for each question. Here are the results. Perceivability was perceived higher when the height of flat surface is 1 mm and when the design of curved surface is 0 mm. However, no significant difference was found among different designs of curved surface on the with-error situation. Tunability, in contrast, was perceived lower when the height of flat surface is 1 mm and was perceived higher when the design of curved surface is handled. Plain comparisons indicated that the existence of text might weaken the role of arrow. No significance was found among the designs of curved surface in with-error condition, indicating that the arrow strengthens users' perception of tunability. A significant difference among the designs of curved surface under both without text without arrow condition and with text without arrow condition. Effect size here suggested that text might weaken the role of desired shape design. For question 2, a marginally higher selection ratio on the with text design than without text design under the with arrow condition, suggesting the combination of text and arrow may afford multiple operations. Tunability was perceived higher when the design of curved surface is handled on the without error condition. However, the selection ratio of 4 mm was higher than handle on the with error condition. A likely reason for this difference is that some participants chose slide in question 2. Pressability was perceived higher when the height of the flat surface is 1 mm, and when the design of curved surface is 0 mm or handle. No significant difference in the with text condition suggested that a single clue might work on a certain operation. To sum up, users can perceive a slight change in an object so that they can understand the designer's intention. However, it's been observed that whatever the design of its curved surface was, people tend not to press or tend to turn the object initially once the error appears. When designers want to afford a simple actionable possibility, using one sign can be more effective. In addition, we found that icons may affect more than text. When it comes to multiple operations, using 2 simultaneous signs could afford multiple possible operations basically. Shape and sign can be combined to strengthen a specific combination of operations. On the other hand, it may lead to a different interpretation. As for limitations, we presented all stimuli on the screen to collect the user's reaction time. Indeed, this is less common when investigating user-product interaction. Furthermore, a larger sample size could give more reliable results with greater power. So our future work will focus on analyzing the data to determine whether other factors affect users' perceptions, and conducting a further study in more practical scenarios with a larger sample size. That's all. Thank you for listening.
Thank you very much. And the next and the last, improving mixed reality prototyping through a classification and the characterization of the fidelity. Chris Cox, he's the PhD candidate at the University of Bristol, focusing on the role of the haptics within mixed reality prototyping. So, Robert, could you start?
Good afternoon. I'm Chris Cox, and today I'll be presenting a summary of our paper, Improving Mixed Reality Prototyping Through a Classification and Characterization of Fidelity. In this paper, we explore how a classification of the dimensions of prototype fidelity can help us to design new prototypes more effectively. This is done through the proposal of a taxonomy of prototype fidelity, identifying the different dimensions of a product that can be emulated through mixed reality prototyping. Over the last decade, mixed reality technology has had a massive increase in capability and popularity. Tools such as virtual and mixed reality headsets, augmented reality, and haptic gloves are becoming widely available, and applications such as Pokemon Go and Amazon's AR View have truly thrust this concept into the public eye. By combining the flexibility and replicability of the virtual domain with the validity and tangibility of the physical domain, mixed reality offers an exciting tool for prototyping that can utilize the benefits of both domains. However, mixed reality covers a broad spectrum, from augmented reality to augmented virtuality, as described by Milgram and Kishino. Identifying where along this continuum to locate a prototype is not a trivial task and will depend on the purpose and form of that prototype. Another key decision that must be made before creating a prototype is what level of fidelity is required. Fidelity is often quoted on a simple scale of low to high. However, this spectrum fails to capture a lot of detail, and its subjectivity can make the distinction between high and low fidelity difficult to discern. To further complicate the problem, when using mixed reality prototypes, we must consider the fidelity of the virtual elements as well. Using this methodology to categorize the fidelity of a mixed reality prototype is difficult and often unhelpful. For example, here are 3 different mixed reality prototypes of the same cordless electric drill. The first is a projection of a digital representation of the drill onto a physical marker when viewed through a camera. The second uses the Spark platform to project a virtual color map onto a blank 3D representation of the drill. The last example uses a virtual reality headset to project a fully colored virtual version of the drill over the position of the blank 3D representation, which can be interacted with. These prototypes would be difficult to place on the two-dimensional spectrum of fidelity previously described, as they all have elements of both high and low fidelity. As such, we propose that a clearer definition of fidelity may come from separating out the different components of fidelity based on how we perceive prototypes. This means that instead of a simple high and low scale, fidelity could be expressed as a profile across these dimensions. To break fidelity down into its constituent components, we've taken the taxonomy of mixed reality proposed by Fink and Schreiber, splitting it into three categories: physical, functional, and psychological. The physical dimension is defined as the extent to which a prototype duplicates the appearance and feel of the object it is representing. The functional dimension covers the extent to which a prototype responds to user inputs, operates, and duplicates stimuli present in the operational environment of the prototype in the same way as the object is representing. The psychological dimension is slightly more abstract and is defined as the extent to which the user perceives the prototype to be an exact duplicate of what it is representing, and therefore behaves and interacts with it as they would the real product. Within these three main categories, we've identified a number of subdimensions that can be used to further specify the exact fidelity profile of a mixed reality prototype. Within the physical dimension, we break down the subcomponents of the haptic and visual categories that make up the appearance and feel of a prototype. Within the functional dimension, the way in which a prototype operates and responds to user inputs is broken down, as well as the way in which the prototype emulates the stimuli in the operational environment of its intended use. Finally, within the psychological dimension, the two key aspects of user presence and agency are highlighted, as well as the importance of representative behavior. By breaking down fidelity into these components, it is much easier to evaluate the fidelity profile of a prototype and to create a clearer target of fidelity for a prototype that is being created. One of the reasons for creating this taxonomy was so that it can be used as a tool to help identify the key characteristics of a mixed reality prototype that should be designed for, based on the requirements of that prototype. Depending on the purpose and the use case of a prototype, some dimensions of fidelity will be more important than others. But creating a comprehensive mapping from all the different types of prototypes, prototyping methods, and prototyping goals to the most important dimensions of fidelity would be a mammoth task. So instead, a case-by-case process is proposed so that designers can identify what dimensions of fidelity are the most important for their specific prototype and what levels of fidelity are required. This process starts by reviewing the taxonomy of fidelity and identifying the key dimensions based on the prototype characteristics. Based on this, the required fidelity levels can be chosen, the virtual and physical components of the prototype can be created, and the prototype can be evaluated according to its purpose. By following this pipeline, prototypes can be made to exactly the required fidelity, with extra time and resources not wasted developing aspects of the prototype that are less important. To summarize, as mentioned previously, a clearer understanding of the required fidelity profile of a prototype will lead to more efficient prototyping. Additionally, the language used in this taxonomy could also be used to assist communication when evaluating the prototype. Another key opportunity that requires further investigation is the potential to use the virtual domain to influence the user's perception of a prototype. There has already been some work to show that the visual cues of the virtual domain can influence the user's perception of the physical domain. This is still a largely unexplored field, especially within prototyping, but it offers the ability to make instantaneous virtual changes with perceived effects in the physical domain, potentially speeding up design iteration. Some of the key challenges that face this research include quantifying the fidelity within each of these dimensions. While it is valuable to identify the different dimensions of fidelity themselves, it will be necessary to clarify what high and low fidelity actually mean within each dimension. Another challenge will be creating an easily digestible way of presenting the overall fidelity level of a mixed reality prototype. One solution to this could be to use radar plots to create a fidelity map of sorts, though further work is required to test this. And finally, the importance of the different dimensions of fidelity should be investigated. Different product classes and types of prototype will depend on different dimensions of fidelity, and these relationships need further investigation in order to fully understand how best to use mixed reality prototypes. Thank you very much for listening. Any questions would be welcome.
Thank you very much for such a very interesting presentation. And I also found lots of questions in our Q&A. So we would like to start from the presentation one for the question to the Charlies. So the first one should be the question from James. James, if you like to have the direct communication, please join our. Please have audio to video on and unmute yours. And his question is could you elaborate on how age was applied to the renders? Is there a function in the software? Did you validate the renders look their age with some real products? Yes, especially the final one is a similar one.
Okay. Yeah. Thanks, James. Well, thanks everyone for your questions. You really took me up on the desire to have a discussion. So yeah, James, I guess the aging was done through the software, and it was done by essentially mapping images and textures onto the products. They weren't validated with real products per se, but we took the mappings from, I guess, images of that material aging over time. So we know that that's what the material would do, but we can't actually guarantee that when applied in that product, it would age in exactly that way. You know, for example, with the chair, the place where you sit would probably age a bit quicker than places where you don't sit. So somewhat validated, but not quite.
Cool. Yeah. Cheers. Thank you, Charlie. That's really interesting stuff, because we're looking to explore the area of like design for end of life, but understanding how in-service life impacts how your product ages and how people's perceptions on whether shall I keep it or shall I not. Really timely, really interesting research. Thank you.
Thanks, James.
May I continue myself questions to James? Probably that's a bit closer, interesting. And how do you think the effects of the artificial texture or the inconsistency of the might happen perceived impression between texture and patterns?
So I didn't quite understand the question. Sorry, do you mind repeating?
Because you use the rendering, so the texture itself will not be changed between the prototypes, but the pattern is aging. So how do you think about the effects of that on the impressions?
So do I understand it that you're saying, like in our survey, we just viewed it visually, but then texture is likely to have another effect? Is that the right understanding?
Yeah.
Yeah, I think I think it absolutely would have an effect, to be honest. One of the big challenges that we had, and I imagine Ayn and Yulan to the same extent might have had, is when we're doing these types of studies, we have to control for so many factors, and it was quite frustrating for me as a designer, because I know that things like texture or the emotional value of a product when you own it can have an influence. So I can't give you an answer other than we would love to try it. We'd love to experiment with that, but I don't have an answer for that.
Thank you very much. Probably the reason is that this could be the common difficulty among us, so maybe we can discuss later more. So, and the next question for you is from the Thomasin. Yep, and please join if you like. And then his or her question is regarding the experiment. What is the sample size taken, and how were the participants chosen? Also, how were the answers measured in the surveys, like the Likert scales or others? And it was, for example, the emotion cards used to measure participants' emotions.
So the total sample was just over 200. So we needed a minimum of 25 participants in each of the 8 groups. The the questions were, yes, we used Likert scales, and I guess the wording of the questions, we used scales developed by my co-author Blijlevens. I don't remember them off the top of my head, but I know that they are listed in the paper itself. So she has done previous work developing scales for things like aesthetic appreciation.
Okay, thank you.
No problem. Thanks.
Thank you. Let me see. Do you want to add comments to his, or that's enough?
No, I just wanted to kind of, they were pretty basic questions, but I just wanted to know how the data collection methods were. So thank you.
Okay. So the next question to Charlie is from Mark. Really interesting presentation. Could there be an inflection points with agent product appreciation? I wonder if up to points to people want to new, and then motivators go towards old vintages. An example would be the guitars.
Thanks, Mark. So in terms of the inflection point, we did, I can't remember which product it was, sort of visually there was a suggestion of a, not a full inflection point, but a kind of a step in terms of the, I guess, how can I put it, the willingness to discard seeming to slightly flatten out towards the end of the older looking products, which I got pretty excited about until we found that it wasn't statistically significant. So it's possible, but again, it would need a bit more testing. And I think I'll cover your second question because I think it's related as well. That it would be interesting to do this again, but with a kind of pre-aged material. So imagining that when you first buy the product, it has some aging patina effect already, and whether that sort of suggests to the user that this is a different type of product and it's supposed to be old, and therefore it could be marketed as, you know, something that you hang on to rather than being purchased with an expectation that it's just stays brand new and then you get rid of it.
Mark?
Yeah, no, thanks. No, it's a really interesting, I suppose, a really interesting study and a really interesting topic of conversation. I think it followed on for some of the other ones that we had in the design for longevity session yesterday. And yeah, I suppose linked to the second question is about kind of how you can, whether an answer to sustainable consumption is making longevity of products something that could be is cool. It could be people desire to have sort of old things, because in like fast fashion supply chains, they can't forecast their demand because it varies so much. But what they do is they market it accordingly, such that they incept consumer behaviors. So rather than saying we need to make products that people like, we need to make people like certain products, is another way of sort of looking at how we solve that sustainable consumption problem.
Yeah, and I think you're dead right. I think like the findings were kind of disappointing, to be honest, but what they are, I think the takeaway is that it's saying that it's an uphill struggle to try and implement these behaviors in the context of products that we experience as very everyday now, and that you have to do something fundamentally different in the design to get people out of that kind of expectation. And that, so, you know, doing exactly what you said to inset the behavior via something that's fundamentally different is probably going to be more viable than, you know, just taking something that we are very familiar with, but asking people to accept the fact that it ages.
Yeah, we used to make vintage phones cool again. It's got to be a really hip. If you've got a Nokia 3310 you can pull out, that's what you need.
Yeah, sign me up.
Thanks, Charlie.
Thank you, Mark. And a bit closer question from Chris. Chris also asked you how does the product class and price affect on the consumer's reaction to patina? So, Charlie.
So yeah, really good question. and to be honest, I don't have a clear answer to that. But in terms of choosing which products that we were surveying, we did do a pre-test with a number of different products, and we tried to cover at least a range of expected longevity. So like the phone case being something that you would go through pretty quickly, and then the chair being something that you hang on to for longer. And likewise with that, an expectation for price point, like the phone case is probably going to be cheaper and the chair more expensive. But yeah, so again, kind of hoping that maybe we'd see one product category had different results to the other. But again, it was a hard no. No one likes them.
Yeah. The example. I mean, Mark just ahead of me mentioned the same thing as looking at relic guitars. I was wondering whether it might be kind of like high ticket items that you're dropping thousands of pounds of dollars on, where you're actually expecting it to last a while. When you get that pattern and that aging coming in, actually it's evidence to yourself that actually I've got good use out of it, and you give that much more kind of for the product because you've got evidence of your experience with it. I was wondering whether there is a price inflection point as well as a time inflection point that Mark was talking about.
Yeah, I think so. I mean, I wonder if it's a sort of self-reinforcing thing that if you invest the money and you therefore want to demonstrate that you've got a lot of use out of it, and so you're more likely to. Whereas if it's cheap, it's not maybe quite such an aspiration to have it for so long and demonstrate that you've used it for so long.
Yeah, really good point there.
Thanks. I think that's all of my questions.
Yes.
Move on to the other presenters.
And then probably that is these questions be very related to the previous ones, that what kind of the participants you had for this study. So thank you very much, Chris, for Chris and Charlie for
thanks
this.
Everyone.
And then I would like to move on the next one, that to Ayun, question to Ayun, the third papers from the James. So do you think the designers should be proactive or reactive on users' perception of materials? Very interesting question. We could have a large role to play in changing perception for a more circular economic world.
Okay. Hi, thank you, James, for the questions. Yes, we are trying to understand the consumer responses towards biomaterials. I mean, when we are looking into circular economy, that we are trying to reduce the usage of materials and trying to, it's not just replacing, but trying to propose new materials that can be used to help in the overusage of natural materials. So that's why we are trying to understand on how this material can help consumers, or not just on how they respond, but it also help to identify the potential materials that can be used further in the material. In the product designs or industrial design products. And for that, we also have started a new projects on biomaterials during COVID-19, which not only looking on the potential use of biomaterials, but also how we can relate, the product design in general, how the consumers, purchasing behavior, more towards purchasing behaviors during the pandemic, because we found a very, very interesting result, but I haven't managed to, it's still under progress, so I hope that we could present or share our finding in the future.
Cool. Absolutely. I think, absolutely fascinating work. And I think, it's probably across all the presenters today that we as designers do have that large role to play, that not only understanding perceptions, I think, yeah, of course, it's the first step to understanding people's perceptions, but actually then how we could influence and push towards a society that is more sustainable, tends towards the circular economy. So yeah, really fascinated by all your work. So apologies, I pinned it on you there for answering that question, but I think it's more for all of us to consider how we play this. Thank you very much.
It's okay. Thank you. Thank you for the question.
Yeah, very interesting question. Maybe we can elaborate this question at the end of the session too, in my understanding. Thank you very much. So the next, Charlie's questions to Ian, similar to Chris' question above. Do you have any thoughts on classes of products where you might test implementation? Yes, for yours too, the same question.
Thank you, Charlie, for the questions. Actually, this project is part of a larger project, so we are not just looking into perception, but we're also looking into emotional responses, and we also develop conceptual models that classify these materials and the products, everyday products, into few categories. For example, we have function and practicality. We also have the aesthetic and semantics, and finally we have products under the experience and emotion. So I have presented this finding last year, I think. So we are in the conceptual model, there is 24 categories under these 3 main categories that I just mentioned. So but this time, because this project is related to my PhD in biophilic design, where we are looking only into furniture design with living materials, living organism embedded. But this time we have improved the conceptual model, and I just haven't got a chance to classify or to identify the products, because there's like maybe millions of products. I don't know. So for my PhD previously, we managed to document like 235 or 234 designs that were mainly designed with biophilic design elements. So this time I haven't got a chance. Maybe I and my team could do something about it in the future. So yeah. So
I asked because it's as you probably could tell from the questions posed to me, that figuring out what types of products to try and test these things is really hard. I was wondering if you had some kind of magic answer that I could use for my research, but I guess the answer is that it's hard because, like you say, there are so many possibilities.
Yes. During my PhD previously, I think I did lots of interview with designers who design furniture design with living materials, with living organisms. So yeah, we need to find out from them their intentions of doing the design. So that's how I try to classify. I mean, that's how I managed to classify some of the products or the furniture design, and then and also linked it with the conceptual models that I've developed. But I'm sorry, the conceptual models is not discussed in this paper, but we have in the previous papers as well. If you're interested, you can just find me on ResearchGate. I have all my papers over there.
I will. I'll check it out.
Yeah.
Thanks for the answer.
All right. Thank you.
Thank you. Ayun, I also have the question to you. Did you ask the participants whether they perceive the picture as an artificial or non-artificial? For example, the artificial flower in your presentation, or did you ask how did you perceive it as the insect or flower or more like this?
Yes, I have selected 11 product designs that in the slides I have shown that there's 11 materials that we have classified, and then we choose this furniture design product design. For example, the most stable by Carlos Peralta. This design, we're just using the imagery of the furniture design, and then we ask questions on perceptions towards because it's related to this paper. This paper mainly discuss more on the people perceptions toward practicality, aesthetic, semantic, and familiarity of the products. The materials that was embedded into the design. And and I don't know. We are trying. When I was in London doing my postdoc, doing these projects, we are planning to actually to use the real materials, but because of COVID, so everything is just we have to change the methods and we have to change the procedure. So I think it will be easier for us to use the images or imaginary of the product design. So we managed to contact few designers, and they agreed to participate and let me use some of the images in the survey. So that's the good thing that happened during COVID.
I will have I'll ask you more personally about how to conduct that kind of the experiment later, because sometimes it's very difficult to have the match between the one intended by the experiment and then the one perceived by the examinees. So I will please continue the discussion personally later. Okay, and then thank you very much. So thank you for answering the questions. So we'd like to move on. Thank you very much, Ayan. And then let's go to the next one, to the Yulan's. Yulan's, you have the questions. And from the Charlie, do I understand that the inclusion of an arrow on the dial did not affect turnability? Okay.
Okay, can you hear me? Thank you for your question, Charlie. I'm sorry, maybe my presentation didn't tell very clear. Actually, an error has a strong relation to the turnability. No matter how the shape the control is, once the error appears, our participants tended to perceive turnability, at least at first glance. And in the second question, some of them chose the slidability, but we think one of the possible reasons is that the choice of our word in Japanese maybe led them to have, like, we choose the Japanese zurasu. I don't know how to translate in English, but yes, it's quite subtle difference in the word, but yes, I hope that answers your question.
Yeah, that does. I got excited because I thought, wow, if we don't need to print arrows on interfaces, they could be so much more beautiful and so much more minimal. But I guess printing arrows is still a good idea.
Yes.
Thank you. Yeah. And then the next one, go back to the marks. Do you think you would get the same results if the participants were presented with an actual physical object to interact with?
Okay, thank you for question, Mark. Yes, we used the render this time because we wanted to record the reaction time to compare the differences between the older and the younger adults this time. So for me, I hope we could get the same results in a practical scene. So we are now struggling with considering a rigorous way to collect their behavioral data. Thank you.
Okay, Mark.
Yes, that's great. Thank you very much.
Yeah, actually, your presentation is very clear. So, but in your presentation, in this conversation, you mentioned about the reaction time. So,
Yeah.
have you found any interesting tendency in it, or what kind of result do you expect in terms of reaction time?
Actually, we have conducted the analysis.
Mhm.
We added the age as an additional factor, and the results shows that the older adults show were more sensitive to the text, and the younger adults were more sensitive to the arrow. Yes, that's one of the most interesting findings, I think.
Oh, different between the functions too, not only the ages.
Yeah.
Thank you very much. And then another question from the Chris. Sorry, from Yuri. I guess that your interest results, if confirmed in larger samples, could be used to develop the design guidelines. Do you agree? Do you think the culture or geographic differences could be impacting?
Okay, thank you for question, Yuri. Yes, at least for Japanese, since this time we only asked Japanese to participate in, and yes, I think cultural or geographic differences could be impacting if we we ask some other foreigners in the experiment, and as I mentioned, even the age can change a lot. So I believe that the cultural or geographic difference could affect either. I hope that this answers your questions.
Thank you. Yuri? Okay. Okay, so let's move on to the next question. How much might the touch and feel of the dial, as well as its looks, affects the user's perception of the functionality from Chris?
Okay, thank you for your question, Chris. I think the touch and feel may affect the user's perception of product's functionality, but to my knowledge, due to the consideration on the costs or manufacturing or something else, I think the materials used in dial, especially for electronic products, are limited. So it might change a little bit, but I'm afraid I couldn't tell how much it will be. I'm sorry. Thank you.
Yeah, my thoughts were, because I know you talked about having the front of the dial have a slight curve on it. I was wondering, obviously you're just looking at that on the pictures, but I was wondering actually if people are actually touching it with their hands, might that change their perception at all? But yeah, no.
Thank you. I think a further research on the practical scenario is needed. Thank you very much.
So probably that's all the question for you. Thank you for answering, Yulan. Great. Arigato. And then the next one. So the last to the Chris questions to the Chris. For the first from Mark, how is the behavior as a psychological different from the function?
Yeah, good question, Mark. It's a tricky one. That psychological element is very ephemeral. It's kind of difficult to quantify. But the idea of the function is if you take the example of being in a car, the function would be if you turn the steering wheel, does the direction change? If you put one on the dial or one of the toggles, does the indicator go? Whereas the environmental kind of representative behavior is the person that's actually interacting with that car, are they interacting with it in the same way that they would in a real car? So if you look at a driving simulator, for example, there's no risk of you crashing. You're not going to be late for dropping off your kids. You're just in a driving simulator. So your behavior might be different. Even if all the buttons that you press do the right thing, you might not have that you might not be behaving the correct way due to a number of factors. It could be task related, it could be immersion, it could be the graphics might not be good enough, and you might think, I'm not in a real life driving situation. I'm in a simulator. So there's a lot of things that impact it, but they are slightly different.
Great, thank you. Yeah, I suppose it's a bit like the tail wagging the dog, isn't it? Because even though the designer or the user is operating the drill, you're actually saying the drill is kind of also operating the person and making them behave a certain way. So what are their behaviors through the use like?
Yeah,
Thanks,
and it won't only just be using the drill example. It won't be the drill itself. It'll also be the environment that they're interacting with the prototype. If they're just in like a clean white room, it might be different as if they were in like a workshop and they've got work pieces in front of them. Their perception, their interaction with the drill and their behavior will be different.
Brilliant. Thanks, Chris. Thanks for clarifying.
It's a pleasure.
Thank you. So probably Charlie, you can please make the question directly. You have.
Sure. Yeah, I realised it was quite a long one in the chat. So I had a quick look through your paper, and in Figure 4, which I think you showed in the presentation as well, you kind of talk about like assessing the I guess like the effects of fidelity. And I've done some studies with like talking to designers and about how they deal with fidelity and prototyping, and they know about it. They tend to be kind of good at it, but it's always really just, it depends. It's always that answer. It's like, and I just wonder, with that kind of, I mean, you're creating a taxonomy. Will it ever be possible to have a generalized guideline of, for example, that the impact of visual fidelity will always supersede functional fidelity when you've got either a designer or a stakeholder reviewing a prototype?
So I think the answer is no. I don't think you'll ever be able to have a complete mapping, and it's always going to be so subjective because it'll depend on like the class of the product you're doing. So for example, a phone versus a hand drill, they're going to have very different kind of things you're looking at. So I think that's why when we were looking at that process diagram, we kind of left it up to the designer because they're going to know the situation they're in the best. The idea of this taxonomy was to try and put some language around it, try and put a bit of process around it to help make that decision. But obviously at the end of the day, it is going to have to be up to that designer. I think there in the future work we talk about that it'll be really important to actually try and have some overriding like generalizations that might be good to look at. So for example, if you're communicating something to the stakeholders, in general the visuals might be more important. If you're communicating something to someone that's actually going to be using it, maybe the function might be a bit more important, but those would be still very high level, and that will need further research to just guidelines. But it is slippery, as you said. It's a tricky subject.
No, I mean, it's definitely hard, but I guess I'm particularly interested from the perspective of teaching design, and it's all well and good a designer saying, oh, well, we just know, but then when you're teaching students who don't know, how can you give them some sort of guideline of when they're prototyping, that where they should be worried about, say, function, and then where they should be worried about other factors. So anyway, I guess,
it definitely needs further research. Yeah, but no, you make a good point. For teaching, it is so important. I think in that case, it's just going to have to be experience is going to be the, not in an industrial scenario, but creating educational like projects you're doing at university that try and capture the importance of like who are we prototyping for, what level of definition is there in the product, so people can try and work out, okay, how do I need to create this prototype? What are the important kind of domains or dimensions of fidelity that I need to hit? What are the ones that aren't important, so we don't need to worry about that and waste time on it?
Yeah, no, absolutely. Thanks.
Thank you, Charlie and Chris. So lastly, the Yuri's questions. Have you checked that the taxonomy is universal, or does it apply to some categories or products only? Do you think that through the taxonomy, you could help designers to balance the realism of the prototype and the time spent to create these prototypes?
Yeah, that's a good question, Yuri. And so talking about does it work for everything, as we've discussed, all products is such a massive scale. You can't really say definitively, yes, this will work for everything. People will be able to find exceptions. The idea of creating this was trying to create something that hits most of the tick boxes, that kind of addresses most of it, that you can use as a general framework as much as possible. And as we use it in other scenarios, you might be able to iterate it, add things to it, try and make it slightly more comprehensive. So hopefully it's fairly universal, but no, I don't think it'll be fully universal. That would just take more and more iteration. Talking about balancing realism and what is required of the prototype, yeah, that's a really big part of what this taxonomy was about. Is it's trying to identify how good do we need our prototype to be, how high fidelity does it need to be, and not worrying about taking it too far based on what the requirement of that prototype is. If that answers your question.
Thank you very much, Chris. So we have 5 minutes left here. So I'd like to wrap up this session. Throughout all the presentations in this session, it is obvious that the design experience is not only comes from the product design, but the user's perception. This session, actually, can we regard users collaborative designers? Or if yes, how can we co-design with users for better design experience? Or in other words, Jamie's question is very close to my interest. How can we count such an uncontrollable design factors in the user perception or living biological materials even? So can we ask the answers for this for each of your presenters? Anyone, please.
Sorry, could you repeat the question? I didn't quite catch it.
How can we count on such an uncontrollable design factors, the user's perceptions, as a designer or the researchers?
Well, it is such a difficult problem, isn't it? Because obviously perception it's a qualitative thing. It's so hard to quantify. So I think a big part of it will be trying to create ways of understanding how we perceive things, and trying to turn those, or trying to relate how we perceive things into design techniques and design methodologies. And once we can kind of create that mapping between them, we might be able to understand it a little bit better.
Thank you very much. How about you? How about you? Are you probably that is the similar question from James of the proactive or reactive, how we can act as a designer? You're also the designer? Are you?
Sorry.
In my understanding, you also have the background as the designer. Right?
Yes, but I'm not really active doing any design currently. So I have produced like artwork on biophilic design. That I have this artwork, living artwork that that was embedded with succulents and cacti. So yeah, you I think you can see it. You did saw it in my first page of presentation. So that is one of the artwork that I've published. I mean, I have exhibited in Malaysia. Yeah.
Thank you very much. So Kachali, right there.
I'm sorry, I got distracted by a chat question. Could you repeat?
I mean, like this, the user's perception cannot be controllable from the designers. So how can we count on such uncontrollable design factors as a designer or something?
Yeah, it's really hard. I guess I think we just can't control, but I think ultimately a partial answer to that is that we need to do the research like this, the sort of thing that we're doing, so that we can at least try and capture the breadth of potential perceptions, and that I guess with the more research we do, and I think what we saw in Yulan's data is kind of an example of this, that we get these archetypes where we can have a greater sense of confidence in the way that someone will appreciate a product. But I guess when we approach new types of designs, there's so much hard work in doing all of that research to get to a point where we have that confidence. So it's tricky, but I guess the fact that there isn't an answer is maybe more fuel for the need to do this kind of research.
Yeah. Thank you very much. I'm sorry for my a bit confusing question, because my background is also collaborative design with the user, so participatory design. So that's why I have the interest in this area as the user's perception. Sometimes users can be also the designer. So I think that we have the great areas we can explore from the understanding about the difference of the user's perception. Thank you very much for this fruitful and very active session. I really also appreciate the audience and who made lots of questions. Thank you very much, presenter, audience, and then this session will be closed. Thank you very much.
Thank you.
Thanks very much.
Thank you.
Thank you. Bye.